We spent a good amount of time thinking about this merge procedure, that if I have two sorted arrays, I can merge those two arrays into one larger sorted array by looking at only the top item from each of those original sorted arrays. But you may remember that that required us working from this foundation, this base case, of arrays that have only a single item in them. So we take a larger array and we split it and split it and split it until we have only single items in each of the sections that we're looking at from that array. We looked at the complexity and the effort that's required to merge two arrays, and that was pretty good. That gave us good performance on that merging step. However, to know the full performance of our algorithm and to think about how it will actually work, we need to think about how many merges will need to be done. How many levels of merging will need to be done. And to know that, we have to know how many times we split and dealt with a smaller and smaller portion of that array to get down to those single item arrays. So I've set up some sizes of different arrays, how many items are in that array, and I want you to think about how many times can that array be split in half until it has only one item left, because we're going to be looking at halves of the data, then quarters of the data, then eighths of the data, and so on. So how many times does it have to be split to give us those single item arrays? So pause the video and think through on this, and in particular, think if you can find an expression, a mathematical way to talk about this for n, for any size of an array as well. All right, let's start easy on this. So if I have an array that only has two items in it, let's say A and B, then we can quickly split that down to only single items after one split. If I have 4 items, well, I split them into 2, and then I'll be splitting them into ones. So that takes only 2 steps, 2 splits, to separate them out into single item arrays. If I had 16, it will get split into 8, then 4, then 2, then 1, so that will take 1, 2, 3, 4 splits. If I have 32, well, that splits into 16, then 8, then 4, then 2, then 1, so that will be 5 splits. And if I have 128, that will get split into 64, then 32, then 16, 8, 4, 2, 1. So that will be 1, 2, 3, 4, 5, 6, 7 splits. Now, you may recognize a familiar pattern in this, or you may not. But essentially what we are asking is, what power of 2 gives us a list of size 2? What power of 2 gives us a list of size 4? And so on. We know that 2 to the 1 gives us a list of size 2. We know that 2 to the second gives us a list of size 4. We know that 2 to the seventh gives us a list of size 128, and so on. So we're asking this maybe familiar question of 2 to what power gives us n? And you may recall that answering that question uses the mathematical function of logarithm. Log base 2 of n equals the number of steps that it will take for us to get to that single item, or number of splits, as it were. So the number of splits will be defined by log base 2 of n. So n items will need to be split log 2 of n times. So log 2 of n. So that tells us how many splits will need to be done to get down to single items. We hopefully logically realize that for every split we do, we have to do a merge step. So we will split log n times, and then we will merge log n times. And we'll have to consider that those merge operations take some amount of work. They have some computational complexity. We will have to do that much work log n times. So this will help you to think about the complexity of our merge sort algorithm as you look at sections B and C of your activity today, thinking about, okay, the complexity of merge, which we looked at before, will be done log n times. And so you'll be able to get a little more feel of the performance and perhaps a little more of a feel for the actual operation and how you could implement a merge sort as well, considering that we have to do these log n splits on our data to handle splitting up the data into those single items, which we then can use our merge operation on to make them into pairs, and then groups of 4 and groups of 8, and so on. Good luck.